1990 AB4, the radius of a sphere is increasing at a constant rate of 0.04 centimeters per second. Now we have time involved. So now they've introduced this time ordeal. Okay, make sure you're paying attention. The volume of a sphere with the radius is R is V equals 4/3 pi r cubed. So there we're talking about the volume of the sphere. I like that because they give us the formula. Don't you like that? Okay. Now they don't give you area formulas, they give you volume formulas because you aren't going to need an area formula here. Does everybody realize that? Okay, we'll get to that. Part A was probably the easiest part for you guys. You probably just knocked that out of the park. You're like, okay, at what time of the radius of the sphere is, or sorry, at the time when the radius of the sphere is 10 centimeters, what is the rate? What is the rate of the increase of volume? So I want to find dV dt when what? When R equals 10 centimeters. That's what I'm after. I know dr dt. What's dr dt? 0.04 centimeters per second. I have a formula that relates these two variables. Its volume equals 4/3 pi r cubed. So let's take that. All right, let's find its derivative. Since they both change, I can't plug in yet. You never can plug in unless you know they're not changing.
It's 4/3.
4/3. What we're going to do. All right, so here we go. dV dt is equal to 3 times 4/3. What's going to happen to the 3's? Cancel. We'll get 4 pi r squared times what? dr dt. Now what do we do? Plug in variables. So we're going to plug in what for pi? Or sorry, what for r? Get it right. Golly. 10 squared times 0.04. This is really nice because you end up with 10 squared is 100. 100 times 0.04 is just what? 4. 4 times 4 pi is what? 16 pi. What's the units? Centimeters cubed per second. And what is that as a decimal? 265. I would accept either answer. That is plus 3, and you get plus 1 for doing the derivative correctly. You get another plus 1 for plugging in the correct values, and then a plus 1 for the answer. Now, the way they do related rate problems now is they also give, they probably wouldn't give you 3.2, they probably only give you 2, and then they give you 1 point in the final answer. Like, after all the parts combined, they'll give you 1 point for doing the units correctly throughout all 3 parts, or all 4 parts, or how many parts there are. Part B, I think is awesome. Okay? And you've got to know what it's asking. It says, at the time when the volume of the sphere is 36 pi cubic centimeters, what is the rate of increase of the area of a cross-section through the center of the sphere? Now, when you read it right away, you should just read through it and say, I'm not even going to try and solve it. I'm just going to read it. Just read for understanding. And you read it, and you're like, okay, I understand what I read, but it still is like Greek. But now go back and read it again, all right? At the time, so I want to figure out at some time, specific time, when the volume of the sphere is 36 pi cubic centimeters. So I know this. I know the volume of the sphere is this. So V equals 36 pi cubic centimeters. So just write that down. I know that. What is the rate of increase of the area? So I know the volume's changing, right? Okay, this thing's getting bigger. This sphere is increasing at a constant rate. So volume's changing. The radius is changing. And apparently, the cross-section through the center of the sphere is changing. Okay? So I want to figure out what is the rate of increase of the area of the cross-section through the center of the sphere. So I want to know dA dt when something. And I don't know the when yet. Actually, I do know the when. I want to know when the volume is 36 pi cubic centimeters. I'm videoing, so I'll let you do.
Can I have that?
Oh yeah, I ran those off too.
What?
I ran those off and forgot to email them to you. But here, you can just have it. Where did I put it? Where did I put it?
Where did he put it, guys?
Black binder.
The three-ring binder, black binder.
Here it is. It's in the very front.
Thank you.
There you go. So volume is equal to 36 pi cubic centimeters. And I want to find dA dt. Now, go back. What are they talking about area of a cross-section through the center of a sphere? Yeah, if you think about a sphere. take a cross section, one slice through the center, the shape's going to be a circle. So we're talking about the area of a circle. So what's the formula for the area of a circle? Now here's the problem. I got area is equal to pi r squared. I've got area and radius related, which is actually a good thing because we know the rate of change for the radius is always what? And the key there is constant. It's always 0.04. It doesn't matter. So it would be nice if I knew what the radius was at this specific time when the volume is 36 pi cubic centimeters. So I want to figure out this. This is what I'm relating. I'm relating area to the radius. All right? But what I want to know is when the volume is 36 pi cubic centimeters. So what I want to do, I want to take the volume equation, 4/3 pi cubed, and solve for the radius when it's 36 pi cubic centimeters. So I'm going to take this volume right here. Volume is 36 pi. I know volume is 4/3 pi r cubed, correct? And I'm going to solve for the radius when that's true. And that'll be the specific time that I want to find the rate of change for the area of the cross section of the sphere. And it's increasing. So watch this. I'm going to take, how do I solve for r? Yeah, you can go ahead and cancel pi's and then what? Multiply by 3/4. So that'd be 4 goes into 36 how many times? 9. 9 times 3 is 27. So I got r cubed is equal to 27. Take the cube root of both sides. What's r equal? You got a point for that if you found r equals 3. Okay? So once I get r equals 3, now I know, okay, I want to find dA dt when r equals what? See, before, it was when, listen, it was really, I wanted to find dA dt when the volume was 36 pi. But that doesn't help me here because I don't have volume in here. So really, it's when r equals 3 is what I'm after. Because when the volume is 36 pi, when the volume is 36 pi, r is equal to 3. Does everybody see how I found r? Does that make sense now? All right, so we got r equals 3. So let's take the derivative. So we're going to have dA dt is equal to 2 pi r times dr dt. So I want dA dt. So dA dt is going to be equal to 2 pi times what for r? 3 times dr dt, which is 0.04. We already knew that. And if I multiply that out, I'm going to get, I think it's 0.24 pi. But what is 0.24 pi? 0.754. What's the units? Centimeters squared per second. And you'll get the last 2 points for finding the derivative. 2 pi r dr dt. So dA dt is equal to 2 pi r dr dt. You get a point for that, and then you get a point for the answer, 0.754 centimeters squared per second. Now, here's what Billy proposed. Billy says, I went about this completely different. So what I tried, I didn't do it right because I never took a derivative. But what he tried to do is he says, you know what? Here's the area formula. He tried to rewrite the radius.
Yeah.
It actually does work, but he never took the derivative. He tried to take the radius, he solved for the radius in this formula, and plugged that in and rewrote the area formula in terms of volume. And then he got it and blah, blah, blah. But then you had to actually find dVdt. Since you're not given dVdt, you would have had to go back and find dVdt when r is 3. And which meant more work. So that would have just been a nightmare. Huh?
It was a nightmare.
You done? What do you need help on?
No, wait.
Wait 1 minute, let me finish this. Okay.
Morris, what if I did
Look at the
everything
answer.
Don't look
right?
at that.
It's just
No,
What?
What if I did everything right? I forgot to multiply by dr. It's like I took the derivative.
You forgot to multiply by dr dt?
Yeah, so my answer is exactly what it should be because now
You
it's
solved it
the-
right.
0.04?
Yeah.
That'd be minus 1. All right, part C. You good with that? Now, part C is just legit. I think part C is easier. I think part B was pretty hard. Because the thing, it's not super hard, but you got to really think. Okay, wait a minute. They're giving me volume in here. How's that helping me? Well, I gotta solve for the radius. Okay, and if you figured that out, then it was doable. Part C is doable if you understand. I mean, it's this big hump that's really not that big. But it is huge if you don't figure it out, because literally you can do nothing on this problem if you don't identify what the hump is. And here's the hump, or the mountain, or the obstacle, or whatever you want to call it. At what time when the volume and the radius of the sphere increasing at the same numerical rate? So I want to figure out when the rate of change for volume and when the rate of change for radius. It seems like a big obstacle, but it's really not, because here's all you're after. Can anybody tell me? If you knew that, this problem was simple. Because that right there is 1 point, by the way. That was 1 point, because knowing that really is the key to the whole part. If you knew, that's what I'm trying to do. Because guess what, guys? I know dB/dt. You found it in part A. It's 4 pi r squared dr dt. Everybody with me? 4 pi r squared times dr dt. And I want to know when it equals dr dt. That right there is another point. When you actually substituted 4 pi r squared dr dt in for dB/dt. Knowing how to set that up. Now, some people are like, do I need to put the 0.04 in? It doesn't matter if you put the 0.04 in or put whatever number in, because what's going to happen to the dr dt anyways? Watch. Everybody ready? drt is going to cancel. And then you get 4 pi r squared equals what? 1. Now you solve for r. Watch what happens. You're going to get r squared is equal to 1 over 4 pi. You take the square root of both sides. You're going to get r is equal to 1 over 4 pi, which is also 1 over the square root of 2 pi. Or sorry, I didn't do that right. It'd be 1 over 4 pi squared 1 over 4 pi, or 1 over 2 root pi. And I don't care how you do it, but you will get 0.282 centimeters. There we get 0.282. Now I had some people get 0.88. That's because they didn't type it in the calculator correctly. If you type in your calculator 1 over 4 pi, you better have the whole thing in a square, and you better have the 4 pi in parentheses. Otherwise it will think it's multiplying by pi instead of dividing by pi. Very true.
True.
Okay? You like it? How many think that was actually pretty doable?
That was the best one.